Hello, my name is Mohammed Shima, and I'm very excited to share our case study on Cisco Systems, a very large IT enterprise networking company. We will be looking back at its turbulent times when Cisco Systems bought into a massive enterprise resource planning implementation project after their legacy system crashed catastrophically. The stakeholders felt that going the ERP route would be the best upgrade option for their system. This project finished by the expected time of 9 months, but there were numerous issues that arose during this project which could have easily been avoided or remediated. Some of the key issues that arose during this project include the mismanagement and poor handling of the legacy system, which led to the crash, the sheer amount of scope creep that occurred throughout the ERP implementation project once it began, the inaccuracies of the test environment compared to the production environment during the pre-go live phase of testing the ERP software before it's deployed to the production servers, the use of technology practices that were just unsafe, and simply the overall lack of management throughout the project. Starting off with their legacy system, Cisco's technical framework was in a dilemma. The IT staff was constantly at a battle with the legacy system. There were bugs, so employees used workarounds, but because people used workarounds, it caused more bugs and instability. Randy Bond, a director in manufacturing and eventual co-leader of the project, put it really well. The system constantly being in need of a band-aid just made it a hindrance to the growth of the company and the overall productivity of each department. To further add on to the problem, the legacy system's instability meant that scaling the system, if the company were to grow at its rapid pace, would be a very difficult to a near impossible task. Finally, the catastrophic failure mentioned previously happened. The system crashed for 2 days straight. This was a very bad look for Cisco to its customers, and the additions of many other day-to-day issues prior to this, the legacy system had to be replaced.
During the testing phase, there were four main issues that arose. The first one is sequential testing. During the testing phase, Cisco tested each individual process instead of running all of the processes simultaneously. This means only a single department was running at a time. Yet Cisco should have performed an additional test at minimum where they tested multiple departments together. Cisco's testing team should have performed a simultaneous test of all the departments as well as to identify any additional possible problems. As for the second issue, transferring to a live database, due to inaccurate testing and a shortened time of testing, the database when it went live resulted in an unstable system. As for the third point, hardware infrastructure, Cisco should have considered implementing necessary hardware for their infrastructure for their users. Because of insufficient hardware within the new infrastructure, it resulted in their users experiencing extreme difficulties. As for the fourth issue, capacity capability, the responsibility of solving the hardware capability problems and capacity problems resided with the vendor and not Cisco, which means Cisco had to wait until the vendor solved the problems pertaining to the promised capability and capacity problems, which resulted in costing Cisco money and time as they were losing a client a day.
One of the issues that Cisco had to tackle was scope creep, which is an issue that affects the project schedule and budget while compromising objectives and milestones and occurred due to adding modifications to the ERP system, which eventually led to an increase in project costs and a lack of progress. In addition to that, the scope of the project had to be expanded to not only address certain technical issues, such as how the systems communicated with one another, but to include a new approach using a data warehouse, allowing Cisco's applications to access a single source of information, the complexity of the project and the workload of the team. All of this had to be managed and prioritized by the IT department, which meant that they had to focus on the main project and stray away from other projects. This was seen as a problem because the department was made accountable for the implementation of the system and was put in greater stress to complete.
One of the main issues faced by Cisco was due to a lack of project management. First, the team had a rush schedule to complete the project. They wanted 15 months to complete this project, but was given 5 months instead. As a result, the employee training sessions were compressed from 5-day training sessions into 2-day, 16-hour sessions. Second, there was a lack of a cost management plan. In the case study, as stated by Pete Solvik, the Cisco Systems Chief Information Officer, there wasn't a formal business case. Instead, he said, "We put this whole thing together without really being that far into this program. We just looked at how much it touched." Shortly after, he said that the team focused on the issues of the system. So there was not much of a consideration when it came to a financial plan. They only touched the surface of the project and did not go into detail when it came to planning.
The incident that created the challenges in the case study was the database failure. When the database malfunctioned, the legacy system reared its ugly head and dragged Cisco along for an expensive and trying ordeal. The engineers used a workaround to perform their duties as the legacy system was cumbersome and bottlenecked effective workflow. There was certainly an underlying legacy systems issue, but examining the exact cause of the incident reveals a distinct procedural issue. One of the regular system operations did not follow a safe procedure, nor is there an effort to correct this issue. After all, there wasn't any apparent issue as long as the system was working, and if the engineers found a faster way to do their jobs, full steam ahead. The shortcut that the engineers used would malfunction, resulting in outages across Cisco. This is a lesson in why we need procedures. If the engineers had followed procedure, there likely would not have been a malfunction. This can also be described as technical debt, an issue where an organization forgoes organized procedures to acquire a short-term benefit. In this case, they avoided upgrading the system by agreeing to use a risky shortcut.
So the legacy system was extremely unstable. What could have Cisco done to fix this? Cisco could start by taking a DevOps approach and use CI/CD pipelines for deploying new code changes. This would ensure that if implemented correctly, the code changes would first be deployed in a virtual or remote environment, and if the code changes pass certain tests, such as unit tests or functionality tests, only then will it be deployed to the production environment. Something like this can be done with the use of Jenkins, and for more details on using Jenkins and an introduction to testing, you can visit the link displayed on the slide. Let's assume that Cisco has set up Jenkins with a source code management tool like GitHub. What can they do next to further ensure the stability of their live system? The management of each development department needs to create strict guidelines for pushing code to production. A good guideline to implement, for example, would be pull requests in GitHub when merging new code changes to the main codebase. Pull requests can ensure that there is some sort of two-person verification, and you can also have Jenkins as a verifier as well. Finally, as Cisco applications continue to evolve, it would be imperative to create new types of tests that are relevant to the current state of the application. In order to stay on top of this, Cisco should consider creating test teams whose sole purpose is to create new types of tests for code changes.
To resolve the issue of scope creep, Cisco should have developed a thorough project plan that would define their goals, objectives, budget, and time needed, which would result in setting expectations for the team and limit the potential of scope creep. Cisco could also have established a process that requires all changes to the scope to be looked through, approved by a project manager, and documented. This would result in keeping up to date with the changes of the project's resources, budget, and timeline. Another solution Cisco should have done is to monitor the implementation and costs of the ERP regularly to identify any issues early on and take action if possible. Lastly, and most importantly, Cisco should have communicated with team members and stakeholders on a regular basis to make sure everyone understands the project scope and objectives. This helps to prevent misunderstandings and resolve issues that stakeholders should have.
Today we're going to be looking at 3 things Cisco should have done during the testing phase. The first issue, which could have been prevented, is user/client prevention. Cisco could have reduced or maybe even prevented their users from a mass amount of trouble if they simply spent the money and time in purchasing additional hardware and extending their projected time for the project. Granted, this would have cost Cisco more money and upfront, it would have, in the long haul, kept their clients and reduced their clients' trouble from accessing the new database. The second issue is simultaneously testing prevention versus sequential testing. If Cisco had tested the database simultaneously instead of testing the process individually, then they would have greatly reduced and prevented some of their major problems. As for the third prevention, which Cisco should have done and could have done, is vendor dependent on hardware capacity capability. The problem pertained to hardware capacity capability, which could have been prevented if Cisco purchased additional hardware or tested the database with the vendor hardware simultaneously with the new database before deploying the new database.
To better manage the project, the Cisco team should have rescheduled their start date. As previously mentioned, the team originally requested a timeline of 15 months, but got 5. Therefore, they should have negotiated with the Board of Executives to explore the possibility of extending the timeline from 5 months to perhaps 8 or 9, maybe 10 months, finding a middle ground. This approach would help mitigate scope creep resulting from time constraints. Next, developing a cost management plan would have enabled the organization to accurately estimate and control project costs. By doing so, this could have led to their formal business case with supported evidence to present to their stakeholders and their senior executives.
One thing that Cisco should have done better was to have efficient communication. In the case study, it stated how the first problem that the company had gotten was because of an issue with the hardware vendor. The unusual contract Cisco had acquired had different terms. It was unique to the situation. The contract stated how the hardware should be based on promised capability, not specific configuration. The project was already being pressed on time. The confirmation of needed hardware should have been a priority for Cisco. I believe that if they had efficient communication, this wouldn't have occurred. Communication has to be clear and concise and often repeated for the point to come across. With the project being such a big risk for the company, the confirmation of both parties should have been a priority for both of them, making sure that everything was accurate since they had an unusual contract. With added efforts of efficient communication between Cisco and the vendor and other potential partners, this issue could have been resolved and prevented.
Hi everyone, this is the last thing that should have happened instead for Cisco. Cisco do not rely on the IT department. So what I mean by that is that this group decided to rely so much on the IT department for them to fix their work, for their system. Cisco wasn't aware of what was really going on. They didn't have much knowledge on their entire system because they were waiting for every time there were to be an error that the IT department would fix it. This happens to all of us too, I get it. We go through a problem and we rely on the IT department. But as a company, Cisco should have had their departments know much more about their own system instead of relying on someone else. They didn't know any effects of the system as well too, so if something were to happen to it, they don't know what would be the cause and what would be the effect of it. This goes for a lack of equal work. Not all the departments were included and they weren't putting in the same amount of work that the IT department was putting in. This is cause for unfairness and everything. No one's going to want to work in an environment that's not equal. Cisco relying on the IT department caused a delay in their success, delay in their system to work. They were relying so much on the IT department that if they all got together and put in the same amount of work, they could have possibly gotten their system to be more successful much sooner. Going off of my previous slide about what Cisco should have done, which was not rely on the IT department, what they will do now is involve all of their departments actually. So this actually gives a sense of teamwork. Instead of relying on the IT department, if representatives from all the departments came together during the planning and the implementation, they can then go back to their team and inform them on the entire system, inform them on what the plan is, how they're going to implement it, what can go wrong. This allows for the acknowledgement to go back into everyone. So this allows everyone to be aware of what is going on in their own company and what is going on in their system. This allows for no confusion and better success since everyone is on the same page. Having all the departments work together as well also ensures that each and every single department was heard. Say you're working in another company and say your department wants to talk to someone higher up on how to fix something. You have a big idea and they're not listening to you. They're not even trying to hear you out. They don't plan a meeting to meet and any of that. You feel like you're not being heard. So Cisco, if they involve all the departments and each department can share their concerns, their thoughts, it kind of gives a sense of reassurance that everyone's working together, that this company can like work together and you can be heard. This also gives the power to people and the will for them to do more. If people are feeling like they are being heard, they are going to want to help more. They're going to want to work more together. So Cisco, we will now be involving each and every single department to achieve our success.
Today, I would like to discuss 3 important topics related to software development and project management, legacy system, and scope creep. Firstly, let's talk about legacy system. As you all know, designing a relational database is a critical aspect of any software development project. In order to ensure the success of such a project, it is initially to design a well-structured database that includes all the necessary tables, such as an employee table. In addition, it is equally important to design an intuitive user to interface that allows users to early browse, edit, add, and delete data. This will enable team members to work more efficiently as well as reduce the likelihood of errors and inconsistencies. Furthermore, a robust business logic layer is critical of managing employee and generating reports. This layer should include functions for employee management, such as adding and deleting employee information. Additionally, it should be capable of generating various reports, such as employee report based on different flagging, etc. Now let's move on the topic of scope creep. Scope creep is a common problem that can lead to project delays, increased costs, and reduced quality. To avoid this, it is initially to establish clear project objectives and plan in advance, as well as ensure that team members have a clear understanding of their responsibilities and constraints. Additionally, regular evaluation of project progress is important to identify and address and scope creep as soon as possible. This will help ensure that projects are completed on time and within debugs that achieve project success. In terms of project management, effectively communication and collaboration are critical. Adopting mature project management methods such as PMI and Prince2 can also help ensure high-quality implementation of projects and plans. Continuous evaluation and improvement is also important to identify areas for improvement and make necessary adjustments to the plan. In conclusion, by adopting a structured approach to legacy system design and efficient project management practice, we can minimize the risk of the scope creep and achieve project success. Thank you for your attention.
Moving forward, Cisco should focus on implementing a project communications management plan, which would move the company and the project into a positive direction. Some issues that were raised during the project were the IT staff feeling overwhelmed. In the case study, they were quoted having to bore most of the responsibility, which led to them deprioritizing other ongoing projects they were working on. Another issue was the promised capability with the hardware, which pushed them back in time. I think that moving forward, having a strong project communications management plan would help solve the internal issues in specific teams and the external issues when having to deal with any outside company or partners or vendors. Communication is key to having a project be successful. Having every member involved with addressing potential major or minor issues. Implementing efforts on having a project communications management plan would make sure information is being understood and that any issues could be prevented before having to take action.
The incident was caused by a failure of a legacy system. This followed the engineers using an illicit method of accessing the database. This was a break from procedure and resulted in system failure. We need to verify that employees do not regularly break procedure. If an employee needs to occasionally break procedure, then they should be allowed to. We hire educated and talented people that understand how to fix problems. We can't expect to have a failsafe for every failure. However, they cannot break procedure to do regular work. Accessing a database should not diverge from procedure since we access databases regularly. In the case of the engineers, their shortcut could be seen as acceptable since doing so allowed them to accomplish their work faster. The part that we need to change is not making that a regular operation. If an employee needs to use shortcuts often, then we need to verify that these shortcuts are safe. Ultimately, this reliance on a shortcut could be used to help justify a system upgrade. In the future, we will pay close attention to our employee feedback and understand better when we need to upgrade our workflow. Regular operations should adhere to procedure, but in the case that an employee needs to break procedure to accomplish their duties more effectively, we will look into the workflow and assess the value of adjusting it.
To summarize what we've learned, throughout our presentation, we covered 5 main issues that pertain to Cisco's implementation of their ERP. We took you on a journey of possible prevention measures in which Cisco could have taken. Next, we reviewed possible solutions pertaining to Cisco's ERP process, as well as our presentation covered 5 key points, which are the legacy system, scope creep, testing of ERP, and lack of project management, as well as unsafe technology and practices.